Hello everyone. In this video we will discuss about the dissociation constant for water. So let's do a quick recap. So we know that water is an amphoteric substance. So what is an amphoteric? It means the substance can act as an acid, also can act as a base, right? So we have seen in our previous example that water can also act as an acid, also as a base. So let's do a quick recap. So we have water is reacting with this pink water to give rise. So the blue water gives the proton away, so it becomes OH minus, and the pink water accepted a proton from the blue one. So now it becomes OH2. Oh no, it's pink. So it becomes OH2 and then it becomes positive charge. So the blue one is our acid and the pink one is acting as a base, and that's why we call water is a amphoteric substance, because it can act as an acid and also act as a base. But this reaction happens in a very small amount. So this reaction is actually in equilibrium, and the equilibrium is more biased towards the left side. So this means, so when you see an arrow that goes longer to any directions, that means that side which is on here is gonna be predominant. So in this case, our predominant side would be the left side. We're gonna have very small reactions that would give OH minus and H3O plus. So you don't have to write like this. You can simply write as H3O plus. Okay, we're gonna use the pink color here. H3O plus. Okay, so what is the equilibrium constant for this whole equilibrium reactions? So the equilibrium constant would be, so I'm just gonna keep things simple for now, let's not complicate it. So we assume this is a equilibrium reactions. So the equilibrium reactions for this one, so this is liquid, this is liquid, this is aqueous, and this is aqueous. All right, so the equilibrium constant for this reaction would be concentration of product divided by concentration of reactant. So who is the product here? So the product here is OH minus multiplied by, who is the reactant? H3O plus. And who is, sorry, not the reactant. So we got two products, OH minus and H3O plus, so that's what their concentrations. And who is the reactant? Reactant is H2O pure liquid, H2O pure liquid. So we got two reactants, H2O liquid, H2O liquid. But again, since these are pure liquid, we can ignore them in the equilibrium constant calculations, because these are pure liquid, there is no change in concentrations. Okay, so our equilibrium constant becomes like this. It's called K equals to OH minus concentrations multiplied by H3O plus concentration. So this equilibrium constant is written as Kw, which is called dissociation constant of water, because the water is dissociating into OH minus and H3O plus. So that's the number. So people have found out experimentally that the concentration of OH minus and H3O plus actually equal. So the concentrations is equal. Obviously it's gonna be equal, right? If it's normal water, they're gonna be dissociate 50-50. It's gonna be equal, and the number is experimentally, it's been found out, is 1 into 10 to the power negative 7 molar, and that's at 25 degrees Celsius. So this is the concentration. So this number is an experimental number, which is the concentrations of water, well, the concentration of OH minus and H3O plus in water at 25 degrees Celsius is going to be 1 into 10 to the power negative 7. So if I use 10 to the power negative 7 here, what's the number I'm going to get? I'm going to get, so OH minus concentration is 1 into 10 to the power 7, and H3O plus concentrations is also there, so it's going to be multiplied by 1 into 10 to the power negative 7. So you're gonna get 1 into 10 to the power negative 14. So that's the dissociation constant of water, K, 1 into 10 to the power negative 14. All right, so right now you know that this is the neutral water. So when the water is neutral, the concentration of each component is going to be 10 to the power negative 7, and the product is going to be always 1 into 10 to the power negative 14. So if in a solution, so let's do a problem. So questions. So if in a solutions concentration of H3O plus is 1 into 10 to the power negative 3, what would be the concentration of OH minus, and is this solution acidic or basic? So let's try to solve this problem. Is this solutions acidic or basic? So what are the things given here? So things that are given here is concentration of H3O plus. So this is what given to us. So let's write that down. So we're gonna solve this. So what is the concentration of H3O plus? This is 1 into 10 to the power negative 3. I'm saying one thing and writing one thing. 10 to the power negative 3 molar. All right, so okay, 1 into 10 to the power negative 3 molar. We can ignore the molar for now because we're gonna work everything in molar, so let's just ignore for now. And the question is asking what is the OH minus concentrations. All right, so this is what we know. Okay, so let's go back. What is the dissociation constant of water? The dissociation constant of water is 1 into 10 to the power negative 14, that we know. And how do we find out? It's equals to H3O plus multiplied by OH minus. And which one do we need? We need OH minus because we know the concentration of H3O plus. So let's do the math. 1 multiplied by 10 to the power negative 14 equals to H3O plus is 1 into 10 to the power negative 3 multiplied by OH minus, and we want this, so let's move this number to the other side. So 1 into 10 to the power negative 3 was multiplied here, so on this side it will be divided, so it's gonna be 1 10 to the power negative 3. All right, so this is the number that we're gonna work with it. So how do you solve this problem? So it's gonna be 1 into 10 to the power negative 14 minus 3. So that number is gonna be 1 multiplied by 10 to the power negative 14 minus plus 3. So that number is gonna be 1 into 10 to the power negative 11 molar. Okay, so that's the concentration of OH minus. So always know the dissociation constant for water is always going to be negative 14. So both of the product H3O plus and OH minus should be negative 14, 10 to the power negative 14. So now we know that, so let me rewrite the whole thing again. So the water is dissociated into OH minus. Okay, so what was our H3O plus concentration was? It was 1 into 10 to the power negative 3 molar. And we just calculated the OH minus concentration is 1 into 10 to the power negative 11 molar. So which one is more? So this is more, right? So when this is more, so this is a bigger number, guys. So if I have to write this one would be 0.001 and this one would be 0.00034 5 6 8 9 10. So the 10th one, so this is, so which one is a bigger number? This one is a bigger number, right? So when you have more H3O plus, when this is more, the solution is acidic. All right, so that's the answer. So let's do a quick recap. So if water is neutral, the concentration of H3O plus should be equals to concentration of OH minus, and what those numbers is gonna be? It's gonna be 1 into 10 to the power negative 7 molar. And if the water is acidic, then the concentration of H3O plus is gonna be a bigger number. So this number is gonna be higher than OH minus. And opposite would happen if the concentration is basic. So it's gonna be H3O plus is gonna be smaller number. Okay, so make sure you understand this portions. So let's stop this video here.